Hello everybody, I welcome you all to NCAS Geology class. In my previous lectures, I have already discussed what is sampling and what is assaying. Now, I will discuss about the reserve estimation, how the sampling data is being used for reserve estimation. Before we discuss reserve estimation, we should know what is reserve and what is resource. Let me talk about reserves. Through geological investigation, the ore deposits are being discovered, and the preliminary survey which is conducted to locate the mineral deposit is the recognition survey, and it is followed by a detailed survey or exploration in order to know the quantity and quality of the minerals available in a mineral site. So, recognition survey is followed by exploration in order to find out the reserve of any mineral deposit on Earth's surface. So, let us know what is reserve. They are the part of mineral resources of a country that are economically viable and have been fully evaluated based upon many geological and non-geological parameters with no legal or engineering obstructions for mining. So, here in case of reserve, a good number of samples have been collected and it has been analyzed, and the reserve estimation has already been made, and the reserve estimated is coming under a proved category. That is, the estimated reserve will not vary much from that which will be obtained through actual mining, because reserves are estimated through a number of samples. So, reserve is the fully evaluated deposit that have been studied in detail and they are economically viable. Economically, such deposit can be recovered. Mining can be possible. But when you talk about resource is a broader term. So, besides the reserve, the resources include the ore bodies which are unworked and which may become a potential economic interest in near future based on their intrinsic geological properties and plethora of non-geological factors such as market demand, feasibility to transport the materials, cheap and sturdy technology of extraction and processing, wartime exigency, etc. Because we know that there are mineral deposits, but it is difficult to recover those deposits economically because of several factors such as absence of good transport facility to the site where the ore body is occurring, or because of the emergency during war time when profit is not taken into account, and in order to meet the requirement of material supply, the country will have to go for recovery of materials. So, the unworked deposits are subjected to mining under compelling conditions, or because of innovation in technology of extraction and processing, because of the demand in market, the on-work deposits may be taken up for mining in order to meet the demand, emergency demand. So, resources include the reserves which have already been explored and the deposits which have not been worked out. So, it includes all the materials that are available in a country with respect to a particular metal or mineral, and the total resource available, total materials available in a country form the resource, and out of it only a part of it which is fully studied, which is fully explored, which is fully established that it will meet the cost of extraction, cost of mining, or it is economically viable, that forms the reserve. So, reserve is a part of the resource. With increasing accessibility to the ore, with greater degree of geological assurance, and with greater degree of feasibility of economic recovery, a resource become reserve, and in absence of them, the mineral deposit becomes resource. But resource are made reserve in case of emergency or in case of wartime exigency, in case of cheap and steady, by use of cheap and steady technology of extraction and processing. So this diagram clearly depicts that reserve is a part of resource. Let us discuss the ore reserve in detail. Ore reserves are put into three categories: proved or measured, probable or indicated, possible or inferred. In case of proved reserve, there will not be variation in the amount estimated and the amount recovered, because here the estimation of reserve has been made through a number of samples which have been obtained through closely spaced sampling points. So here the reserves are thoroughly assessed in terms of its tonnage and average grade, and therefore it is a proved category. There can be a maximum error in this reserve estimation up to or less than 20%. But in case of probable ore, which is indicated, probable is indicated ore, here reserve estimation is made partly from the sample analysis and partly from geological projections. So here the reserve is likely to meet the estimated. Here the actual mining may meet the reserve estimated, because there is some amount of geological projections. Few samples have been analyzed and further projections have been made based upon geological evidences. So it is probable ore. But in case of possible ore, the reserve estimation is made purely on the basis of geological evidences and projections and not on the basis of the sampling data. There occurs nearby deposit which has been explored and its extension is unexplored nearby areas on geological grounds, and projection is made over that area with regard to the reserve, possible reserve. Because the nearby area is mineralized, it has already been mined and its possibility has been extended to the surrounding area based upon geological evidences and projections. So the resources for a country at the sum total of the ore reserves, uneconomic deposits and deposits which are not yet discovered or hypothetical, all together they form the resource. A part of it which is fully evaluated, that forms the reserve. The same thing has been depicted here in this diagram. Identified ores to be discovered. In case of identified ore, we have the measured, indicated and inferred ores. Again, a part of it is, again these are coming under the zones of economic possibility, proved category and under the zones of economic possibility, and beyond it we have the resources. So this is the diagram which clearly depicts how resource is different from reserve. So reserve is fully estimated, fully established, and in case of resource it includes reserve plus those which have not been discovered and which are discovered but not of economic value. Together, all together form the resource. The economic and marginally economic resources turn into mineral reserves with increasing degree of geological assurance. The sub-economic deposits may become economic with changing technology and socio-economic or political situations. Now, let me discuss how reserve is being estimated. In order to estimate the reserve, first the volume of the ore deposit must have to be found out. And if after the volume is found out, it is multiplied with specific gravity to get the reserve, again to get the tonnage. And it happens in case of CGS system. But in case of FPS system, if the measurements are made in case of FPS system, then the volume is divided by the tonnage factor, so that the total quantity of material in a ore body or the tonnage of material available in the mine, that can be estimated in terms of metric tons. So what is tonnage factor which comes into picture in case of FPS system? Volume is divided by tonnage factor. What is that tonnage factor? Tonnage factor represents the number of cubic feet in a ton of ore. It is determined by a simple formula, that is tonnage factor is 2240 divided by 62.5 into specific gravity of the ore. It is the number of cubic feet of material. So when V is divided by TF, it gives the tonnage in FPS system. This is simply a constant factor which is coming into picture because of the FPS system. While estimating the reserve, one practical point is always to be remembered that in nature the weight of the material may not exactly be equal to the theoretical formula. It is because the ore body might be porous or might have fractures and cavities. That's why this point will have to be kept in mind when the reserve is being calculated. For ascertaining the reserves correctly, the deposit is usually subdivided into a number of ore reserve blocks on a plan with each sample point, that is borehole, pits, as a unit. For each of the ore block, the area of influence is determined, and this area is multiplied with the true width of the ore body to find out the volume at the concerned point. In case of deep steeply dipping ore bodies, the vertical longitudinal section is used. The area in this section is converted into the area on the plane of the ore body by multiplying it with the dip factor, which is the deep length of the ore body for unit vertical depth. In an ore body dipping 45 degree, the dip factor is 1.41. So, dip factor we will have to take into account so that the vertically drilled length is brought over the dipping surface, and the dipping ore body, the surface area of the dipping ore body is determined, then it is multiplied with the width or thickness to get the volume of the dipping ore body. If it is horizontal, simply the area is found out and the width is multiplied. This is the area, the width is multiplied to get the volume. In case of dipping ore body, the dip angle is taken into account. This data is being converted to this one. This depth is converted to this one by taking into account the dip amount, and this length is, this length is found out, this width is found out, so the surface area on the ore body is found out, and then it is multiplied with the thickness to get the volume. So here the dip factor comes into picture. The tonnage of individual blocks are added up to get the total tonnage. The average grade of the deposit is obtained by the additions of the tonnage multiplied by the grade of the each block and by dividing it by the total tonnage. So this is the formula. Now let me discuss how the volume is being calculated. Volume is calculated by geometrical method. Volume is also calculated by graphical method. So how geometrical method is useful for determining the volume, that I will discuss in my next lecture. Thank you all for giving a patient hearing to my talk. Thank you.